So in this video, we are going to be talking about arithmetic sequences, and arithmetic sequences are when there is a constant increase or a constant decrease within our sequence. So in this case, if we look at our sequence we have 3, 7, 11, and 15, so on after that. So the best way to start one of these problems is with a table. So on the left, I'm going to write step, and on the right, there's going to be term. And so the first step, the first number we have, our term is going to be 3. The second, it's going to be 7. The third is going to be 11. And the fourth is going to be 15. And as you may have noticed, just off your observations, we see we are increasing every single time here by a certain number, that one being 4. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. So this plus 4 that we have right here is known as our common difference. And so our common difference, sometimes denoted with the letter D, is going to be the number which we are increasing or decreasing by each time in our arithmetic sequence. And so before we go ahead and start writing equations or formulas for these, another thing that we should point out is going to be the notation. So we have the first one, which is going to be a sub n, and that is going to be the nth term of the sequence. So this can be any term in the sequence. So let's say the nth term, let's say it's a sub 50. That's going to be telling us what the 50th term is in the sequence. And so another important one we should keep in mind is a sub 1, which is going to be the first term in the sequence. And so for the first term in the sequence, for our example here, step 1, it tells us the term is going to be 3. So our a sub 1 in this first example would be 3. Now, there are two types of equations which we write using arithmetic, and that is going to be our recursive and our explicit. So our recursive, that is useful for telling us the next term. And so our formula for our arithmetic recursive is going to be a sub n, so our term is going to be equal to a sub n minus 1, this is a little bit different, we'll get into that in a second, plus our common difference. So in this case, a sub n minus 1, what that is this is our previous term. And we'll get into that in our example here. So let's say we're trying to find the fourth term in our sequence. The fourth term in our sequence we know from our table is going to be 15. Well, let's say we only know our third term. So let's say we're trying to find a sub 4. So it would be putting in 4 for n. We'd do a sub 4 minus 1 plus our common difference. Our common difference, which we saw above, is going to be 4, so positive 4. Now, let's think about this. The previous term, it's the one before that. So before the fourth term, again, we don't know the fourth term yet. We know the third term. It's going to be 11. So a sub 4 is equal to our a sub 3 plus 4. Again, we know it is 11. So a sub 3 is 11. So substitute that in for 11 plus 4. And let's do some basic math. 11 plus 4 is 15. So that means our fourth term in our sequence is going to be 15. And that makes sense. So it's just essentially telling us that whatever our previous term is, plus our common difference, because it's increasing by that common rate, our common difference is going to be what our next term is going to be, which is 15 in this case. So that would be how our recursive equation works here. So again, that's only useful really for telling us what the next term is. And so to help us find any term, we would use an explicit formula. So our explicit, again, this is going to tell us any term. So let's say we want to find the 100th term, the 200th term, the 50th term, the 17th term. That's what we'd use the explicit formula for. So we'll start again with a sub n telling us any term in the sequence is equal to, we're going to have our first term here, a sub 1, plus our common difference times n minus 1. Now let's use this again, using our information that we know. Let's just plug in our information. So we'll have a sub n, we don't know what that is yet, is equal to our first term. We do know what our first term is. In this case, it's going to be 3 plus our common difference, which is 4, times n minus 1. We don't know what n is, so n minus 1. And now after that, what we can do is we can distribute and then combine like terms. So 4 times n and then 4 times negative 1. So we'll have a sub n is equal to 3 plus 4n minus 4. And we combine like terms, so we'll have a sub n is equal to 4n minus 1. And so that would be our explicit equation which we have. And let's work and see if this is actually true. So let's say we want to find the fourth term again. So a sub 4 is equal to 4 times 4 minus 1. 4 times 4 is 16. So say a sub 4 is equal to 16 minus 1. 16 minus 1 is 15. And would you look at that? It tells us that our fourth term in the sequence is going to be 15. So that would be how we find our arithmetic explicit and recursive equations. Again, recursive is useful for telling us the next term. Explicit is useful for telling us any term in the sequence. And so if there's something to take away from this, it would be these parts right here. Hopefully you found this video useful, and I wish you the best of luck.